All right, so we've been talking about enthalpies, which is represented by delta H. There's a whole bunch of different ones. You can have F, C, you can have nothing. But all enthalpy really is the heat at a constant pressure, and heat can be measured by MC delta T. So heat is the flow of energy. And so this is why we always have a delta H, because we don't really talk about the enthalpy of something. It's relative to something else. So we can go and find heat using our lab. We did a lab like that. MC delta T, you measure things, you go and find it, and then you can go and write, figure out delta H's from that. So that's what you actually do in real life, but chemists, we tend to not be able to go to the lab because it takes a long time, and so we kind of work our way around that. So we got the bond energies we talked about, so you can go and you can figure out how much energy it takes to break bonds. So in this case, we need to break 2 hydrogen bonds because it's to balance out the equation. We need to break out 1 oxygen bond, and we form 4 HO bonds, and we can do that. And so it's, remember, break minus make gives you your delta H. And this is normally for the reaction, so this is for 2 moles of hydrogen and 1 mole of oxygen, and this is the only time you really see the reactants minus the products, because remember, normally we're talking about delta, which is a change, which is the end minus the initial, so that's products minus reactions, but bond energy it's not. So that's one way to find delta H's. We have delta H of formation, which is common to have a table of, and this is at 25 degrees Celsius and 1 atmosphere, which is like what it normally is around for room temperature. And we had to set things to 0 for this, and so element form is 0, so this is your O2 gas, or your carbon that's in graphite form. And then we talked about delta H combustion, right? And also for delta H's, we can do that for other things. And what we do is we write a balanced chemical equation where we make 1 mole of the substance that we're interested in. We have combustion, where we take something like hydrogen, we're going to combust it with oxygen, and we're going to form some water. If we were doing a combustion one, we'd do 1 mole of hydrogen, so we'd have to divide this through by 2, so you'd actually end up with a half. You have delta H in general, so that's your enthalpy, it's the change. And we can have endo or exothermic. If it's endothermic, it's going to have a positive delta H value, and if it's negative, it's an exothermic reaction. So that's the summary. It's not real hard. There's a whole bunch of different ways for it, and that makes your life a little bit difficult, but you just have to learn the different ways. The last way we also learned about was Hess's law. So if we add up a whole bunch of different reactions, whatever reaction they end up being is they add up to.